Okay guys, here I am back again. It's been about 8 or 9 months since I put out a video. Finally got moved into my new shop. I'll do a shop tour of that at a later date. But the first thing that I want to do is to go on to the next part of milling the cylinder head for the 9-cylinder radio. We've got I went ahead and rebuilt the, this is actually my third wedge tool that I've built. They all ended up having problems with one another. The biggest problem that we had was the breakdown of these areas right in here. I'll try to get a little better view of that. And what would happen is that you're putting so much pressure on one end with the socket head cap screw you had in there that it was causing breakdown of this area here, and you're losing thread contact, and wasn't able to hold the piece squarely in the block and pull the piece out or shift it around. There was all kinds of things that were going wrong that I just didn't have any control over. So what we decided to do is I went and I found a bolt that was fairly close in size to, quarter 20, and I machined both ends of it down, as you can see here, and I cut the threads on each side quarter 20, and I put quarter 20 nuts on each end. So we're tightening it from both ends. That way this wedge tool doesn't tend to break down as much, and it tightens it in a lot better than it has been. I've been having all kinds of issues that I haven't started to film, and I couldn't finish the filming because this thing was coming out and I couldn't tighten it down no matter what I did. So, and remember, when you make this wedge tool, if you're doing the same thing I am with the 9-cylinder radio, when you make this wedge tool, make it precisely the way they tell you how to make it. If you want to do what I do and just drill out a quarter-inch hole all the way through and have double threads coming out each end with the nuts, that's what I found out works best for me in keeping this piece. This is a tough one to machine, in keeping this piece the size that you need it. So what we're going to do is get on with the machining and just see what happens. In the bottom of this tool is right in here, is where we thread, and it's a fine thread 5/16 inch bolt. Or is it a 3/8? No, I think it's a 5/16. Anyway, what we do is if we can get it in there. A fine thread, I have trouble catching threads with it. Okay, there we go. Get it in there as tight as you can. It's going to tighten up more on the machine as you mill it. There's no way around it. It's going to do it. I don't try to get over tighten it on this end. So now what we need to do is put it in the 3-jaw. Let me find my tool. I have some issues with this 3-jaw. I need to take it apart, see what's going on. That's part of the problem, is we were over tightening this one so much that it was causing problems internally with my chuck. But I think we've got it to the point now where it works. Remember, these are 25-degree angles, and that's the same angle that the cylinders are in relation to the bottom of the cylinder head. Cylinder towers, I should say. Try to tighten up each jaw, take up that tension so we don't have any more slippage than we need to have. out. Does that look good? Bring you in a little bit further. Okay, first thing I need to do is machine this square. We're going to do these one cylinder head at a time. We're going to machine this square for 25 degrees like everything else, and we're going to bring it down to dimension this way, and then we're going to cut the fins with our 32 thousandths inch high-speed steel tool, drill the holes out here, and then we'll be done with that end of it. Then we're going to have to flip it around and do the other side. So we'll get started. And I'm using, for a tool, I'm using a CNMG going across, which I think is a pretty good tool for that purpose. And we're going to get it over here close till it just touches. Okay, back it off. Okay, now we're ready. So the x-axis, we're going to zero that out, and we're going about 20 thousandths on the first pass. I think I'm going to run this probably at about 260 RPM. I'll get the rotary started. This is a slow process, so I'm not going to show too many passes here until we get to the next section or get to the end of it. As you can see, we're just starting to take off this corner here. I'll bring you back when things get a little bit more interesting. Well, we went about as far as we could on getting the top machine flat. We've got that pretty well done. We don't have our correct dimension yet with this area right here. Is still impinging on where the top of the cylinder head is going to be. So we may have to machine this area down further. supposed to be 719 thousandths, and it's right at 719 thousandths, but we still have this area right here. All right, what we're going to do is we're going to machine this round. What I'm using is a VCMT tool right now, which is a very thin, elongated V-shaped tool. And so we're going to touch off with that. Get it in there, touch it off, and then bring it back this way. I got the wrong one in there. I'll be right back. I'll change that out. Actually, I might as well just have you watch. I'll just change this one out. Get the right one in there. This is a left-hand tool right here, and I need a right-hand tool. I mean, I had a right hand in there, and I need a left-hand tool. So this is the left-hand tool that I'm putting in. Tighten her down. Always make sure you have your tool good and solidly in the tool holder. This is a BXA tool holder. Yeah, right now we can get in there and do some touching off. First, so I don't have to get him touched off first. Alright, we're touched off. So what we're going to do is advance the Z-axis about 20 thousandths. And just see what we get out of it. This particular operation is really test the holdability of your clamp system. And I'll tell you right now what happened there was that the clamp held just perfectly, but the bolt twisted out of the jaw. So what I'm going to need to do is develop a more rigid bolt so I can hold it in there tighter. And let me check it out first. These kind of things happen a lot in this particular operation. I've made about 5 or 6 of these cylinder heads already, and I've had to scrap most of them. But this one here is not really damaged beyond all repair. It's fine. But this bolt just isn't holding. It's just not enough holding power there for it. So I'm going to go ahead and scrounge around, see what I can come up with, and I'll be back on that. Okay, I narrowed down the problems that I was having with the machining of this part. As you can see, I've done some passes now on the cylinder head, and I have a more robust V-shaped, in the V-class, I think it's a VBMT. I got a more robust one. It's carbide that's been coated. I've had it for quite a while. The holder that I've got right here is, it was a 3/4 inch holder, and I've only got a 5/8 inch space for that to occupy, so I had to machine it down, and believe me, machining hardened steel on one of these tool holders is no fun. But I got it done. And another problem that I had is my compound rest here, I had it way out to the end, the other direction. So I lost a lot of my rigidity in the part. So there was rigidity on two fronts. Number one on the insert, and number two on the compound. So this seems to be working okay. So what I'm going to do is I'm going to show you a few passes, and then we'll proceed on. That's not very fast. Adjust the camera here in the way of my machining process. Liking this depth and this speed, so we'll just kind of continue with it. You want to have it going real slow on these interrupted cuts when you have your power feed, and that's exactly what I'm doing. When I get close to the end, I usually take it off the power feed and feed it in by hand until I hit my 0 point, which is right there. Bring it back up. Bring you back when we get this thing round. One of the things I noticed when I was machining this is that the work holder piece, the wedge, slipped in the lathe jaws, which is real common with doing this. It's hard to control. You know, you'll probably machine 2 or 3, maybe even a half dozen pieces that'll hold this thing in the stock by the time you're done with your 9 cylinders. So I went ahead and indicated it. I've got it indicated to within about a half a thousandth. And now what we're doing is drilling and reaming the 188 thousandths hole through the center of this. And then we have to counterbore it with a 11/64 bit down to 343 thousandths. So I'm going to do those operations now. Always go real slow on these center drills, especially if you're using a little tiny one like this. Here's the drill bit I use for doing the 3/8 reaming. It's one size below the one in the decimal chart. This one goes all the way through. This is where the what is this one down here? Oh yeah. One of the things to keep it from slipping and turning further in here is just periodically clean the chips off the kit so that it doesn't grab. When it grabs is when you're going to have to come back in and re-indicate again because of that chip jam. Whenever I feel it getting a little bit tight, I always make sure that I come out and get those chips cleared off. We're almost through, just a little farther. Taking a little bit longer than expected. Well, looks like we got some kind of wall on the drill bit. Now make it better. Through. Reamer time. Reamers can be extremely frustrating. You don't ever want to force a reamer. You can, especially these little ones, you can break them off very easily, jam your part, any number of things. So you want to go in a little ways. don't have spiral. They don't have spiral flukes, so they're going to jam up a lot more. Unless you get one that's got spiral flukes in it. Felt tip, how deep we need to go with it. It's already starting to make it wobble. And it's done. I'm going to have to check this. I may have to re-indicate it again. Okay. We have our cylinder head. We have it rounded, the exact diameter. We got it flattened. We have the hole drilled for the valve to come into. And we've got the counter bore down to 343 thousandths. Now we're going to start putting in the fins. Now how we're going to do this is we're going to run at about, if I get in there, we're going to run at about 175. We'll find out when we start it. Anyway, we're going to touch off right there. And the first fin is going to be 45 thousandths from the top of the cylinder head. So what we're going to do is we're going to move, using our DRO, we're going to move 72 thousandths, which is going to be the width of the cutting tool, which is 32 thousandths, plus the depth, which is 45 thousandths. So we get 77 thousandths, I'm sorry. More than 77 thousandths, so I have to lock it because the lock is going to pull it back a little bit. Yeah, it did. So a little bit more. Okay. So now the depth is 78 thousandths. We touch off. So we're going to turn it on and make sure we got the right speed. Alright, there you go. 175. We're going to touch off. We have touched off. Set to 0. And we're going to go into 78 thousandths. Have to let the tool do its own cutting. It's so small that it's really easy to run into problems. takes time. For aluminum. Let's see if that works any better. That was going in. Fighting us right now. Normally we don't have these kind of problems with this spinning, but sometimes it is an issue. Remember, this isn't 78,000's overall diameter, it's 78,000's from this side. It's not 39,000's each side, it's 78. One thing I notice is I'm riding a little bit high, so I'm going to bring this down a little bit. Let's see if we get it a little bit more centered. Yeah, it's still riding high. Thought we had it centered, but you never know until you get in here and start machining. Okay, now we'll try again. See if we get down to our 78 a little faster. Yeah, there we go. It's cutting better. Speeds and feeds, position the tool. Tool position. Every once in a while I'll run this tool back and clean it up a little bit. Primarily because it gets clogged up with aluminum and that really impairs its ability to cut. This is one of those situations where the thin bit can come in really handy. I do have some on order. Maybe I'm not going to finish this whole project up with thin bits. Okay, we're 78,000. Now we have to move 64,000, which is the width of the tool plus the width of the fin. So we'll move that out, and that'll give us our next fin. This thing I have to go a little bit over 64 because when you tighten it up, it does tend to go way down. then number 2, and we'll bring you back when we get closer to the bottom. Okay, the cylinder head is now done. Fins are cut on that side. Now all I need to do is go over to the other side to finish up the top of this head. Then there's in part 4 that'll be coming up, there's more work to be done on it. This is one of the more involved parts in the 9-cylinder radio. But as you can see, the top 6 fins are 78 thousandths deep, and the bottom, I think I was only able to sneak 4 in. You're supposed to get 11 total, but I couldn't get that bottom one. So I had the bottom 4 or bottom 5 are going to be 100 thousandths deep, probably because of heat problems closer to the base of the tower. Okay, so we'll see you again on the next round.